Hello, welcome to my channel. In this lesson, we want to talk about factoring an expression completely. Factorizing complex expressions completely, okay? And this factorization is going to involve an identity. Okay? This class is particularly made for grade 9, ICGC grade 9 or ITG grade 9. So we'll continue this way. Now, before we continue, we'll take a look at algebraic identities. Let's look at identities. Some standard identity. Okay? Standard identities. From this identity, we can apply some of them when we are factorizing, okay, and it will make our factorization easier though. So the first of the identity is square of a sum, because square of a sum is a plus b squared. The expansion is a squared plus 2ab plus b squared. This is called the square of a sum. Okay. Identity 2 is square of a difference, which can be written as a squared minus 2ab plus b squared. So this is called the square of a difference, and the expansion is a squared minus 2ab plus b squared. The other identity is what we call the difference of two squared. Difference of two squared is a squared minus b squared, and the factored form is given as a plus b into a minus b. In other words, if you expand a plus b into a minus b, you have a squared minus b squared. And of course, we have this general identity, x plus a into x plus b. The expansion is a squared plus a plus b into x plus b squared. Okay, this is a kind of general identity that can generate identity 1, 2, and 3. The fifth identity is what we call the sum of 2 cube, a cube plus b cube. Okay, so the factored form of a cube plus b cube is a plus b into a minus a squared minus ab plus b squared. Okay, in other words, if you expand the right hand side and you collect like terms, you will have a cube plus b cube, and it is called the square, the sum of 2 cube. Okay, we also have the difference of 2 cube. Difference of 2 cube. Okay, difference of 2 cube states that a cube minus b cube will give us the factored form of a minus b into x squared plus ab plus b squared. Okay, so if you expand a minus b into x squared plus ab plus b squared, you have the sum of 2 cube, which is a cube minus b cube. Okay, these are the standard identities, guys, which we can use to when we are factorizing complex expression. Now let's take a look at example of this complex expression. Examples. Number 1, samples. The instruction is factorize the following completely. So number 1, we are looking at 4x cubed minus 32. So factorizing this, we can take out the common factor. The common factor is 4 into x cubed minus 4 in 32 is 8. Okay, and 8 can be rewritten as x cubed minus 2 cubed. Okay, if you take a close look at this, you will see that this is a difference of 2 cubed. Okay, difference of 2 cubes says we have a cube minus b cube. The expansion will be a minus b into a squared plus ab plus b squared. Okay, so taking a to be x and b to be 2, we can substitute that into this formula, and then we have 4 into x minus 2 into x squared minus 2 plus 2x, okay, plus 2 squared, okay, and that can be simplified further to be 4 into x minus 2 into x squared plus 2x plus 4, okay. Yeah, so x squared plus 2x plus 4 cannot be factorized further, so this is the complete factorization of the expression 4x cubed minus 32, and then we are done with that. Example 2, 3t cubed plus 24. Okay, so first factor out the common factor. The common factor is 3, so we have t cubed. 3 in 24 is 8. Okay, and of course again 8 can be written as a power of 2. It's a power of 2 to be 2 raised to power 3. Okay, and then this is the sum of 2 cubed, and from the expansion of sum of 2 cubed, we have a cubed plus b cubed equals to a plus b into a squared minus ab plus b squared. So taking a equals to t and b equals to 2, we can factorize the expression we have here, and then we have 3 into t plus 2 into bracket t squared minus 2t plus 2 squared, and that can be simplified further to give us t plus 2 into t squared minus 2t plus 4, and of course t squared minus 2t plus 4 cannot be factorized further, so the complete factorization of the expression 3t cubed plus 24 is 3 into t plus 2 into t squared minus 2t plus 4. Example 3, 4x into 2x minus 1 plus 2 into 2x minus 1 all squared. Okay, now guys, factoring out the common factor. The common factor here is 2x minus 1, 2x minus 1, so we can factor that out to give us factoring out 2x minus 1 from the first term, we'll be left with 4x. Factoring out 2x minus 1 from the second term, we'll be left with 2 into 2x minus 1. And then we can open the square bracket. If we open the square bracket, we have 4x plus 2 times 2 is 4x minus 2. And of course, we can collect like terms in the second bracket to have 8x plus minus 2. Okay, and of course 8 and minus 2 has a common factor, which is 2. So if we rearrange that, we have 2 into 2x minus 1 into 4x minus 1, and this is the complete factorization of the given expression. Example 4, x squared plus 8 all squared minus 36 x squared. So this, of course, here we have to expand before we can factorize. So we have to expand the expression in the bracket before we can factorize. So if we expand, we are going to have x squared plus 8 multiplied by x squared plus 8 minus 36 x squared. Okay, and opening the bracket will give us x raised to power 4 plus 8x squared plus 8x squared plus 64 minus 36x squared. Okay, and this if we collect the like terms here, we have 16x squared plus 64 minus 36x squared. Okay, collecting the like terms further, we have x raised to power 4 plus 16x squared minus 36x squared plus 64, and then this can give us x raised to power 4 minus 20x squared plus 64. Okay, now we have to factorize this using the method of factorizing trinomial. Okay, so to factorize trinomial, you have to multiply the first and the last term. That's a plus 64 x raised to power 4. Then you look for two numbers such that when you multiply them, you have plus 64x4, and then when you add them, it will give you minus 20. And those two numbers, of course, are minus 16x raised to power 4, minus 16x squared, and minus 4x squared. Okay, so we have to replace the middle term with minus 16x squared and minus 4x squared, and then the expression will become x raised to power 4 minus 16x squared minus 4x squared plus 64. So which is then we can factorize by grouping x squared into x squared minus 16, minus 4 is common here, into x squared minus 16. Okay, and then pick one of the bracket and combine the terms outside the bracket. You have x squared minus 16 and x squared minus 4. Of course, 4 can be written as 2 squared, and 16 can be written as 4 squared. And then we can see that the two brackets are difference of 2 squares, so we can further factorize them to give x plus 2 into x minus 2 into x plus 4 into x minus 4. And this is the complete factorization of the expression. And we have done with the question. The final example, guys, I believe you are following. X squared plus 1 all squared minus 4x squared. Okay, so we have to expand the bracket, collect like terms, and then factorize again. So if we expand the bracket, there we have x squared plus 2 x raised to power 4 plus 2x squared plus 1 minus 4x squared. If we collect like terms, there we have x raised to power 4 minus 2x squared plus 1, and of course we can factorize this, multiply the first and the last term. We have plus x raised to power 4. Look for two numbers you can multiply to have plus x raised to power 4 and add to obtain minus 2, and of course it is minus x squared minus x squared. So we need to replace the middle term with minus x squared to have x raised to power 4 minus x squared minus x squared plus 1, and then we can factorize by grouping. Common factor of the first two, x squared minus 1. Common factor of the last two is minus 1. Then we have x squared minus 1. Okay, then we can pick one of the bracket and combine the terms outside the bracket. So we have x squared minus 1 into x squared minus 1. Okay, so which can be rewritten as x squared minus 1 all squared. And this is the complete factorization of the expression, guys, and then we are done. So this is how to factorize complex expression. You use the identity where you need to use the identity. You can use the identity to factorize. You can also use the identity to expand, and this is how it works. If you have any question, please put your question in the comment section below, and remember to hit the subscription button so you can receive our next video. See you.